class we look into a voltage divider circuit. Okay. So okay, we look into a small voltage divider circuit so that we can understand how the flow of the multi-sim or the PCB design layout happens. Okay. So today we will be going to some more depth. Okay. Give me 1 second. Let me open the syllabus once so that we can have a complete look of it. Give me 1 second. Okay. So, okay. Is my screen visible? Is my screen visible? Hello.
Yes,
Hello.
yes, 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 sir.
Okay. Okay. So we just look into voltage divider and current circuit. Okay. So last class and we simulated that one too, and we made a small PCB of that one also. So we will look into some small more topics, then we will directly start the fundamental of electronics, atomic structure, Ohm's law, all sort of things. Okay, basics we will go. So first today we will try to design one 7805 circuit. Okay, what does a 7805 means? Anyone can tell me what is significance of a 7805? I think you guys are already BTech pass or somewhere studying in BTech final year or third year. You might be knowing what is 7805 IC used for. Please, can anyone tell me what it's used for exactly?
Adder, subtractor purpose, adder purpose, divider,
I'm saying 7805.
differentiator,
It is 7805. That is LM741. Subtractor, differentiator, that is operational amplifier. It is a op amp where you can make integrator, subtractor, adder, differential circuit. There you can make. I'm asking about 7805. What is that one? Can anyone tell me?
Voltage regulator.
Yeah, correct. What kind of voltage regulator it is? What is the output voltage of that 7805 IC? Any idea? What is the output of the voltage regulator IC? It is 7805. Means it is a 5 volt IC. Okay. So what will the circuit, how it will be? Let me tell you. Small. It is a 7805. Okay. Then what we will do? We will take a input from here in. From here onwards, what we will do? We will try to put a capacitor so that we just delay out the ripple. This should go to ground. This should be the output, and this should again a capacitor below. Okay. So this is our output, B out. Okay, so it is just only for converting a DC voltage. It is a step down. Suppose if you are putting 9 volt to 12 volt sort of thing, so it will, the output will come to be 5 volt. Okay, same. Now in this configuration, if you, let me delete this input line. And if you now want to convert DC to AC, right? So, sorry, AC to DC, what you have to do, you have to put diodes here. Bridge rectification. Okay, we have to do. We have to do here bridge rectification. So we have to do here is bridge rectifier. We will put here. We will put here bridge rectifier. It will connect here. One terminal will go here. Okay. This from here, the terminal will come and it will be grounded. Okay. From here, it will go to the transformer, whatever, which is V in AC format. AC we will be doing here. Okay. Like when transformer we are putting suppose 220 volts at the primary coil, we will get 12-volt AC, not DC. 12-volt AC step down voltage to the secondary coil. From that one, it is connected at this point, the secondary coil, and it will go here, and then this bridge rectifier will convert that 12-volt AC to 12-volt DC, and then this 7805 will step it down to 5-volt DC exact. Okay, so this is how we can build a complete voltage regulator circuit. Okay, give me 1 second.
Sir, here we are using that I see is 5 volts only power supply.
Yes, 7805 is a 5-volt power supply which gives output of 5 volts, stable 5 volts.
Okay, okay. So before we are not using that bridge rectifier, final output should
No,
be.
no, no, no.
Mm,
See, what is the significance of a bridge rectifier? A bridge
ah,
rectifier significance is to convert AC
DC to
voltage
AC.
to DC, AC to
Mm,
DC. Okay.
AC,
So
right.
transformer is providing us 220
Mm,
volts to step down 12-volt AC. Okay, so
okay.
if you connect your multimeter at the secondary coil of the transformer, you will get there 12-volt AC, not DC. Now this
Mm,
AC have to be, because 7805 cannot take DC. Sorry, it cannot take AC. It can only take AC DC. So that AC will be converted by the bridge rectifier to 12-volt DC. Then it will pass on from the 7805. And the first, this is the second circuit. The first circuit was bridge rectifier was not there. In this input line only, what I did, sometime what happens, you have a circuit. Okay, you have a big circuit. In that one, in SMPS, so one power supply 220-volt will be there in SMPS. Okay, and then it will be distributed to everyone, and one center hub will be there from where all the high voltage DC will be passed on. Okay, so some block in the motherboard will require 12 volt, some will require 9 volt, some may require 5.5 volt, 5 volt or 3.3 volt. So wherever 5 volt is required, we will take that 12-volt DC directly to the 7805 and we'll make it to 5 volt. So everywhere it is not required to have to put a bridge rectifier. At any cost, you need 12-volt DC at this centric point. Okay, then it will convert to 5 volt. Either you generate this 12 volt using a battery, or you generate using a power supply, AC to DC power supply, or any transformer which is converting with a full bridge rectifier. That is only the concept of this one. Okay,
Yes, sir. Sir, finally here we get output is
5
AC or
volts.
5 volts, 5 volts
It is a,
AC.
it a DC 5
DC
volt.
only. Okay, okay, okay. Okay, sir. Thank you.
Okay, I will be doing one simulation. Don't worry for that one to show you guys in multisim. Then we will go for our design. Okay, I gave me the wrong one, and I multi-sim. Okay, so Control W. I will go in this one. I will search for that particular device. Okay, so 7805. Okay, so all group 7805 or LM 7805. LM 78. See, 7805 it is coming, 7805 CT. So these are some different. So 7805 we will take here. One, We will take some capacitors, we'll go to all groups, we'll click here, we'll get some passive basic sources, basic. So you will get all sort of thing capacitor here. Okay, we will take some capacitor like this and we'll change the value later. Okay, 1 and 2 I will try to put. Capacitor done. Yeah, okay. Okay, let's connect them first. Okay, we will rotate it. We will rotate this guy. Okay, we will try what we'll do. We will try to connect them first. Okay, we will try to connect them. This is common. Okay, what we will do, we will go here and we will go to sources. Okay, we will take DC power or anything other you can also take. So we will take her DC power here, or you can take some let me first take the ground. Where is the ground here? Ground. Okay, I will just put it here. Then I will take a DC power, so or DC voltage. Where is that voltage? Power sources. Okay, we'll take this one only. Suppose I am taking this one as 100 microfarad. Sorry, 10 microfarad here. It's just a generic, okay? And 100 microfarad here. Okay. And what we will do, we will take this input plus to here and the minus to this end. The output coming from this end, we'll take a multimeter and we'll put here. We'll connect the output here and the ground one at this point. Okay. It is a 12-volt voltage. Now, if I simulate this one, it is passing from here. If you when I click here, see, we are getting 5 volts only. Why? Because let me show you one more. We will connect one more multimeter here. We will first connect here and this will connect below. We will double click here. See 5 volt coming. If I check this one, it is 12 volt exact. Okay. Now I change this to suppose 24 volts. Okay. Now I generate. Again I do, I am here it is 24 volt, but here it is coming 5 volt. Means this block is putting the voltage to down up till 5 volt. Okay. Then if you want to put here transformer with a full bridge rectifier, that also you can put at this point. It will give that same thing only. Let's try that one once. Into W. So we need to get a transformer. Okay. Where was the transformer? See, it is city type and this is center tap. So both kind of available. So it is 3 pole. Okay. This is center tapped and this is city type. Okay, general purpose. And here you will see plus 12 volt ground minus 12 volt. But we don't need this one here. We need this guy here. Okay, this guy we want here. I don't want that particular at this moment. Okay, and some diode. I need some diodes here. Basic diodes. IRFZ44N. Okay. 1N 400. Okay, we take this one, this diode. Okay, we will delete it for now. This 12 volt we will delete. We will come here. We will take one, copy, paste. Okay. Again, we will take both of them, copy and paste here. Okay. Then we will connect it first here. Sorry. Then this guy to this guy, this guy to this guy, and then the from here to here. Okay. Okay. Now we will connect them from here to here, one connected, and one will be going from here to here. Okay. It will go to ground connection, ground line here. Connected. Then we will, what we will do, we will take this one here. Okay, sorry. And one should be at this point. Okay. All connected, all things set. Now what we will do, we will go to again Control W. We will go to power sources. We will look for AC power. We need a AC power here. Okay. What we will do, we will put this guy here at this point. What have to do? We need 240 volts. Okay. 240 volts at 50 hertz. 120 volt, it at 60 hertz. Okay. In India, we use 240 volts, 50 hertz. Okay. 240 volt VRMS and 50 hertz. Okay. Now I will take one multimeter, and what I will do, I will try to connect first ground, and then at this point where I will put one because it is the input line here, and simulate. Here what is 5 volt. I think it is not reading like that. So it is giving 5 volt exactly here, but here actually I guess it is not reading. It is coming in DC voltage. We need here AC voltage. If you put AC voltage, it will give actually. It is actually wrong voltage coming. Normal V is coming actually here. I don't know. Is there any multimeter which can take this one or not? Allegiant multimeter. One second. Wait, let me check once. Okay. I need to check because this multimeter is not configured properly. I have to configure it. See, if you are giving, so here also it is coming because at this point it is getting converted actually. That voltage to 12 volt is stepping down at this point. DC 12, sorry, 12 volt AC. At this point, it is now 12 volt AC. Oh, sorry, sir. So sorry for me. This at this point it is 12 volt AC. Okay. Then this bridge rectifier is converting it to 12 volt DC. And then it is coming to be 5 volt at this level. So this how we try to simulate the whole circuit. You see, actually we are not into the simulations because we are here to design blocks like different. Okay. So this is a circuit diagram of a voltage regulator of 5 volt. Okay. Now suppose we want to make a voltage regulator where we want variable voltage also. 5 volt is fixed. Okay. So we want a variable voltage regulator also. Okay. Give me 1 second. Give me 1 second, please. Okay. So this is a 5 volt circuit. Okay. You can make any like variable also. We can make -5 volts regulator also. So many things are there to do. Okay. So after this is done, see our schematic is ready. It is functioning properly. We can go for making a layout of this one. How to do that one? Let me tell you. Okay. Let me tell you. Okay. 1 second here. Okay. See, we can do PCB design at this part also, which is Alti board of multi-sim only, NI multi-sim only. Alti board is also a tool to make a PCB design, but we are not interested to make that thing here in this one. We are more interested to design it in Eagle for now because we don't want to do it here. We want to do it in Eagle CAD. Okay. So what I will do, I will go to that one to make the proper file. Okay. I don't want to make it here. No, I don't want to. I will go to Eagle CAD to make it. Okay. I will simply, this is Eagle CAD. I will click here. It is opening. Let it get open. Then we will start. Okay. Okay. We will come here. We will go to files, new, schematic first. Okay. We are into the schematic. Now we will go to this add part. We'll click on add part. Let it open. Okay. Then we'll type here 7805. LM7805 and enter. See, it gave us this kind of packagings. Multiple way. The 3 dot packaging is also there. This kind of packaging is also there. So we will prefer this packaging. So some more packaging concept is also there. Okay. So this is also one more type of packaging. So this guy is also one more type of package. So multiple packaging options are there. So we will try to go for this one for now. Okay. Okay. We will take this one here. Then capacitor we will take. We will go for capacitors. So big capacitors are required. So we will try to take this one. Okay. We will put here one. We will put here one. Okay. Now we will go for diodes. Diodes. Diode. Okay. We'll go for a diode here. So 1, 2, 3, and 4. We took the diode. Then we'll go for terminal. Terminal, which is a screw terminal. Why? I'm telling you. I guess it is a screw terminal. I guess it is a screw. We will take screw terminal here. Okay. Like this kind of only it should be. I don't know why it is not coming here. SCREW. Screw. Okay. We want a terminal block at this level, but I don't know why it is not coming. No, this is not the one, not the right one. Okay, so I want something. No, it is not the one which I am actually looking for. 1 second, let me just go through this one to get that terminal block. Okay, so where is that terminal? Yeah, I guess can you find. Here we can use jumper here for now. Okay, we will use jumper for now. Temporary, we will use jumper. Okay, so two we will take. One we will put here, one we will put here. Why I am telling you. So first we will try to connect them. First connection is required. Okay. Then from this terminal only, we will try to connect the systems. Okay. We will try to connect. From here only, we will put our transformer power here. Automatically, it will take up till here. So rather connect a transformer at this level, we can do it like this. Okay. We can go for, okay. So we can go for like this. We can connect it up till this level. Then what we will do, we will connect it here, done. Then seems to be here. Okay, connected. And then this will again come and get connected at this level. So if you see our schematic for this one is ready, where capacitors are there, diodes are there, 7805 voltage regulator, and two terminal blocks are there. Okay, it is done. Now we can save it somewhere. We can save it here like this. And then we go to schematic to board. We will simply go here, press yes. Now we can make the layout. Okay, so to make the layout, what we can do, first we will put this block here, then we will go for these terminals. Okay, so we will go for the input lines where we will put this one. 1 second, JPT2. Okay, JPT1 will be, JPT2 is the output block. JPT1 is the here. Why I am telling this one? We every time should follow the schematic flow. Wherever the block in the schematic flows are coming, we should follow that one. We should not put it here and there. It's not a good thing. If the input is here, and if you put this input at this level, just to imagine how the long routing will be. The connection will how long, then it will create a lot of delay. So that's the reason we cannot do it. So we have to keep it as close as possible. Okay. So capacitor we have to take. So capacitor should be at some around at this level. Okay. It should be some around at this particular level. Okay. So C1 and C2. Okay. I will try to, I will try to keep them here. Why I'm saying, okay, I will try to keep them here at this level. I will try to put them here. I will make some space first, because I don't have much space. I have to keep some space because the capacitors might be bigger. We won't be able to put it properly. So that this space is required minimum. Then I will come to this end. Okay. I will come to this end here and I will try to gather them so that I can get a ample of space to connect. Okay. And then I will try to put this block some around at here so that I can make the connection properly. Now I will go for the diode connections. Okay, I will go for the diode connections now. 1, then 2, 3, and 4. I will just take it like this simply. And what I will do, I will figure them out first. So D1, okay, so how it is being placed? D1, D2, D3. Okay, D3 should be here. Okay, so first what I will do, I will take this D1 here, then this D2 here, at this level, then this D3 here, and then this D4 here. A simple and easy connection to do. But if you see, this circuit is bit bigger. Okay, so we need some smaller circuit to go for. Okay, we don't like this circuit actually. Better what we can do here is, okay, what we can go do here is, we can bring this one down here. We can take these two diodes from here to here. Okay, what we can do here is, we can arrange them properly at this level somewhere. Then we can put this one here, and also this guy at this level. Okay, so it will make it more smoother and proper. So just look into it, it is looking more smoother. Okay, then what we will do, we will try to gather these connections. Okay, we will try to gather them properly so that we have ample of space to go for. Okay, then we will try to put them somewhere here. Okay, we will try to put them somewhere here, and then this one also at this level. Now we will look into it whether we have that amount of space or not. We can do some more squeezing we can do, I guess. We can go for more shrinking we can do here. Like this, I can do it here. Okay, okay. If you now look into it, we can go up. Okay, that's fine. Now what we can do here is, we can start routing. We can start routing. We can take this to some around 20. We do not need much more in compared to that. What we can do, we can start routing here. Okay, we can start routing here completely. One second. One second. I will give this a space a little bit. Rather, I will shrink it. Okay. See, this connection happened properly. Then D1 to D2. Okay. So how we are going to connect it? So minus should be, it should be flipped actually. If I'm not wrong, why this is coming every time here? Okay. Now I can flip this guy, or okay, okay. What I can do here is, I can take this guy from here. I can just bring it some around at this level here. Okay. I will try to put it here. Again, I will try to draw this one. I can do here auto routing also. Okay. I will show you how auto routing happens. Okay. Okay, then what I will do, I will try to gather it like this from here to here and connect it. Then simply I will draw it here like this. Then I will try to, but there is some issue, I guess. Okay, let me do one thing. Let me pull this guy a little bit in the top. So I can just do small routing. Okay. Routing done here. Okay. So if I can do, I can do the routing here. Okay. What I can do here is I can squeeze this guy a little bit. Okay. I can squeeze this guy a little bit so that I will look into it later. I will, okay. Okay. I think it's fine, I guess. Much more not needed. Then what I can do here is, okay, but still there is some issue. See, we can squeeze this guy back also up till somewhere here. We need some space. We are not going for double layer routing. We are going for single layer routing. So then on this cases, some this kind of congestion might occurs. So we have to take care of these things. Okay. Okay. So what we can do here is, see, space is there. That's fine. That should be okay now. And now I want to connect both of these guys. Okay, but there is very difficult to connect, right? So it is very difficult for me to connect here like this. How shall I go? Aren't there any way to connect? Hmm, it's like a puzzle. I can go like this, like this, like this. So that's not a good thing. What I can do, so here comes a jumper. If you know what is a jumper, I tell you what is. See, I drawn one thing here. Okay, I will do, I will go for a higher point. Okay, I will put it here one and one I will put it here. Simple. And then I will try to connect this guy. Okay. I will connect it for here for now. Okay. So what will happen when it will get fabricated? We will put a simple thin wire between this point to this point because these routings will be in the back side. The components will be in the front side of the PCB. We'll just put a simple thin pin or kind of a small wire and we'll solder it. It will get automatically get shorted. Okay, rather routing we do sometime jumping. This is called routing jump. Okay, so we do this one many times. We do this one. Okay, we can make it more shorter. That's not a big deal. Now let's come to this part. Okay. Now if I come at this end, then I will go for this guy from here to here. I will come here. Again, I will go here. Okay. Now if I see all the connections are seems to be fine for this point. Okay. I will just drag it a little bit below. Okay. And okay, after this one is done, if you see our routing is completely done. So this is the routing how we did it manually. So this is manual routing of our PCB. Okay. Now, if I do, I remove all the routings now. Okay. I will remove all the routings for my side. What I will do now, I will go for automatic routing. We did it manually. We understood how it happens. Now we can go for automatic routing once. We'll see how automatic routing happens. Okay. We'll see how much to do automatic routing. You need to go for auto router. This one, sorry, this option. This is manual routing. This is auto router. When we click here, we don't need the top one. We need the bottom layer. Okay. We need this bottom layer. Auto. We'll put here auto. Effort should be high and number of running threads should be some. Okay. Okay. And we will do continue. Once we do continue, okay, it will come here and then we will do simple press start. Once we press start, okay, and end job, you see the whole routing is done. Automatic routing it has done. But the wires are seems to be thinner in this case. So now if you want to make it thicker, thicker, you have to go here at any cost, okay, and then you can make it thicker like this. So you can make them thicker, okay, you can make them thicker like this. Okay, let me try this one. Okay, let me try this guy and change the width to 12. Okay, so we can change it. We can go sequentially, we can go here and we can change the width of that one. Okay, so it is being actually done. So just see the routing. It is with a thin routing they have done. Okay, we can change it. So with the thin routing, what happened? But thin routing everywhere you cannot do. Wherever the high current is there, we cannot do. We have to do less routing on that. Means thick routing we have to go for. Okay. So this is how what we just do the routing of the whole PCB. This is a simple a 7805 block what we routed and we simulated it a multi-sim. Okay, so this is how we will be doing some more complex designs further. So we will go for a transistor based amplifier. We will create some small amplifiers, or we will understand first the circuit theories, then we will go for transistor based amplifier. Then there are, see, many projects are there. See, just see, this is the whole column for the project only. Okay, temperature sensor PCB layout, then other projects also, high speed USB PCB interface, how it looks, Wi-Fi antenna. If you have seen, if you have seen any module of Bluetooth or Wi-Fi kind of, you have been seen on the PCB, this kind of design is there. Okay, let me, in yellow color it should be, in yellow color like this, it will come. Okay, then it, okay, sorry, not like this, it will be like this, it will come, then it will become like this from here. Then it will become like this from here. Then it will become like this. Then it will become one more like this. And at final, we will see one more like this here. So if you have seen this kind of designs in a PCB, these are some kind of antennas. Okay, these are some kind of antennas they have been placed here. Okay, so one end will be connected to some other and some other. So like this kind of antenna will be there, or some this kind of antenna will also be there if you have seen. So let me show you this kind of antenna. Okay, let me show you. Okay, like this kind of antenna you might have seen. Let me show you. Okay, let me show you. I put one, suppose I put one patch here, one patch here. Okay, what I will do, I guess I can do like this. Okay, this like this is for antennas. Okay, this is for antennas we generally have. We generally have this kind of things for antenna. You have seen this kind of things for antenna. Antenna coil will be there like this. How much you want to make big, you can make it bigger. Okay, we can make it bigger like this. You have seen. So this kind of antenna coil you might have seen in some of the circuits. So this is the antenna coil. Okay, so this is how we generally will see antenna coils will be there. You will able to look into them properly. You will see like thin, more thin will be there. It is bit bigger. What I have made here is okay. What I have made here is bit bigger. Okay, you might have seen this kind of small. So these are like antennas. So many things in circuit you will see this kind of antenna. This is called serpentine design. Okay, so this antenna kind of thing will come in the PCB designs. Okay, so this kind of things we work in the things. Okay, let me show you a very complex PCB design. See, these are very complex PCB design. Let me show you a live of this one. I think we should have something inside this one. Designs, prior designs, we can look into it. How? Let me go here. Open projects, examples. Open, let me go here. Design blocks. Okay. Let me, okay, sorry, I don't think so. This is the wrong one. Okay, design blocks. Okay, examples. Okay, see, Arduino board, one example is there. Okay, if you open this one, you will see tons of blocks are inside this one. Okay, so these are the different blocks of a Arduino. Okay, I guess it is a Arduino Uno, or it is a Mega 2560, the big one. Okay, so see, multiple blocks are there in this one. Now if you change to board, you will see this is the board connection. This is how they have made it. Okay, so this will go for fabrication. Okay, so I guess this is a two-layer board. I guess it is a two-layer board only. So they have made it two-layer board in this one. Yes, this is a two-layer board. One top layer and one, the red is the top layer, blue is the bottom layer. Okay, so they have made it like this. Okay, so if you want to go for more complex design, you can go for that one also. If you see Beaglebone is a microcontroller board. Okay, so if you go for this Beaglebone board, it's a very huge block, if you can see here. Okay, so now if you go for the schematic of this one, see how dense it is. Just imagine how dense it is. I guess it is also, I'm not getting what kind, what, how many layer they have used. I think it is also, okay, it is a 16 layer they have used. So just see how complex they have made it. Okay, so the how the placement. So this is how what you guys will be doing in your projects. Okay, so this level of complexity you will going to touch. So that kind of things we have mentioned here. Just see, if you go here and see, so these are so dense designs. Just see, it is a very little one. This is a little one. I think this is a Arduino Uno or Mega or something. So this kind of designs we will be making. See how complex these are. It's a multi-layer PCB. Okay, so we will be going to design complex designs for our projects. Okay, so this is how we are looking into further proceeding slowly. Okay. If you have any questions, you can ask me. Hello. Anyone having question, please ask me. Dr. S.K. Rasool, Uday, Sahana. Any questions, please ask me.
So what about the features, sir, for experienced candidate? What about the salary packages for this PCB design? Experienced
See,
candidate.
PCB design is the most lucrative topics across the engineering industry, okay? Because each and every industry which is working in technology and electronics requires this PCB, okay? You have seen PCB throughout your home. If you open any gadgets, you will see PCB, green, black, red, blue. Starting salary of a fresher in a PCB design is somewhat starts from 4.5 lakhs, okay? Going further with an experienced guy, if you give one or two jump as a starting, you have suppose as a fresher 4.5 you have done, you had a one increment, it became some around of 7 to 8 approx. Then you give a jump, the 8 become 13 after or at a 2 to 3 years of experience, 13 or 14 depends, 12 to 14. Then you give a jump after like 5 years or 6 years of experience, it some will become at least 20 lakhs for general service based company. What I am saying, like HCL Technologies, Capgemini, they hire a lot of PCB designers, okay? Then Tata Alexis. And if you are going for a product oriented companies, lot of product companies across the countries there in India, their salary for an experienced guy as a lead engineer, what is 6 7 experience, it will sum around between 25 to 30 range, because product company salaries are generally higher. You can now compare the parity.
What about here, sir? Any projects, sir? We are discussing about this PCB design. Any design we are doing?
Yes, this class has started only, okay? So I think 2 to 3 classes have been only done yet. So in this one, we will be doing major projects at the end. So see, if you have seen that syllabus, you have seen, see, major and minor projects are there. See, tons of projects are here. If you see transistor based amplifier, Wheatstone bridge, LED flasher circuit, to make you habituated with the tools, okay? And we will be using industry leading tools like Eagle CAD and OrCAD and Allegro from Cadence, okay? So we will be making different PCBs and sort of thing. At the end, the complex one what we will make is Arduino board. Arduino PCB, because Raspberry Pi PCB we can make or BeagleBone we can do, but it will take a lot of time to make. So that much time neither you have, neither we have to align, because it's a 5 months program. Excuse me. So Arduino Uno in the last we will make, or the ESP8266 or ESP32. So these are the small microcontroller boards. ESP32 or ESP8266 are the Wi-Fi based, IoT based microcontroller, and Arduino Uno is not a micro, it's not a internet connected micro, it's a normal microcontroller. You can use different module to connect, but you need separately. So we will either make any one of the things from these three. It will
How
be
much cost, sir? Cost, sir, for this one?
which one?
Cost, I'm asking.
For that one, you need to contact Rajat Kumar Singh, VLSI for All Private Limited. You can see here, he will provide, he has given his phone number. Please contact him. He will align you with all the details.
Okay.
May I
Fine.
know what you currently do?
I'm presently working in some engineering college.
Okay. So if you are working in some engineering college, what subject you teach?
Electronics on AC.
EC. So EC, if you are teaching, might be digital electronics or power electronics or some or microelectronics. You might need to go to lab to see the candidates, right? What they are doing in their labs. You have to give projects to the lab at their odd sem and end sem, right?
Yes.
Candidates, what you have seen, you might be experienced than us because you are teaching currently. So you have seen candidates are doing soldering on a zero PCB boards, right? But you have seen their solderings are not good. Majority, what we have also seen, soldering they cannot do properly. It's like an art, and everyone doesn't have that capacity to do the tenacity.
Yes.
So they do very nasty things. So to minimize this one, what you guys can do, you can implement PCB design, because if you learn PCB design from our side, you will get to know in details many things. You can learn, you can tell your teachers, more colleagues to learn. Okay, so after this learning, you will get a depth knowledge. Then you can, apart from that one, you can tell candidates to make PCB designs in the college and all sort of things, or you can implement in your career growth also, and you can design PCB. Candidates will get to know by sharing you will share knowledge that they will design PCB. It will be easy for you guys to understand their designs, what they have done, because soldering they make horrible. Okay, and it will be again a career growth for you also. If you want to leave teaching profession and want to come to corporate, there is a huge opportunity across the industry. Even fabrication is also present in India with PCB. PCB fabrication, many companies like PCB Way, Lion PCB, then many other PCB companies are there in India.
Okay, okay, sir. Thank you. Thank you very much for
Okay.
the
You can contact Rajat Kumar Singh, VLSI for all private limited. He will guide you with the further things. Okay.
Okay,
Any
sir.
other guys having questions? Any other guy having questions? You can ask, please. Okay, then we can end the session today here, and we'll meet again in the next class. Okay. Okay, then everyone. Bye and good night for today. Hello, Rajat.